Ketchup is one of the most common sauces in the world. People use it almost automatically without thinking. It appears on the table at home, in cafes, fast food restaurants, and street food stands. It becomes part of meals long before we notice it. Ketchup feels familiar. Its color is predictable. Its texture feels smooth and uniform. When we squeeze ketchup from a bottle, we see a single red mass flowing slowly onto the plate. It looks consistent. It looks simple. It looks finished. But ketchup is not a single substance. It is a mixture. Tomatoes are processed, crushed, heated, filtered. Sugars dissolve. Acids react. Spices blend. All of this creates something that looks perfectly smooth to the human eye. Our eyes cannot separate its components. Our brain reads it as one texture, one color, one taste. But the microscope does not see ketchup the same way. Under magnification, smoothness begins to break apart. Uniform color starts to lose its meaning. In this video, I take an ordinary drop of ketchup, the same ketchup people use every day, and place it on a microscope slide. At first glance, nothing seems unusual. It looks exactly as expected. But as magnification increases, the familiar begins to dissolve. Structures appear, boundaries form, hidden details emerge. What once looked like a simple red sauce turns into a complex microscopic environment. This is the world inside ketchup. A world that exists every time we eat it, but almost no one ever sees. At 80 times magnification, the ketchup sample appears as a thick, uneven layer spread across the slide. The surface looks dense and saturated, with large colored regions dominating the field of view. The familiar smoothness of ketchup disappears almost immediately. Instead, the texture appears broken and irregular. Wide areas of deep yellow and orange tones are visible. These regions come from concentrated tomato material pressed flat during preparation. The edges of the sample are uneven and jagged. They suggest how the sauce flows and settles when spread. Clearer zones appear between denser areas. These lighter regions indicate liquid components distributed throughout the mixture. The structure already feels complex rather than uniform. At this level, ketchup no longer looks like a simple sauce. It begins to resemble a layered material built from multiple elements blended together. This first magnification gives a general impression of ketchup as a dense but unstable structure. Even at this scale, it is clear that ketchup is far more than just a smooth red surface. At 200 times magnification, the internal organization of ketchup becomes more apparent. Large structural fragments now reveal clear boundaries. These shapes form a mosaic-like pattern across the slide. Individual regions differ in texture and transparency. Some areas appear tightly packed and solid, while others look softer and more fluid. This contrast creates a layered visual effect. Small rounded formations become noticeable throughout the background. They vary in size and seem suspended within the surrounding material. The distribution is uneven, adding depth to the image. Thin lines and subtle borders run between regions. They separate components that did not fully blend at a microscopic level. The structure feels engineered rather than random. At this magnification, ketchup starts to look like a controlled mixture. Every element appears to serve a role in holding the sauce together. This level explains why ketchup stays thick but still flows easily. At 800 times magnification, ketchup transforms into a highly detailed microscopic landscape. The field of view fills with tightly packed structures and sharp contrasts. Distinct cellular fragments dominate the image. They appear clustered and compressed, forming dense islands within the sample. The boundaries between these clusters are clearly defined. Between them, fine granular material spreads across the background. This creates a textured environment that feels dynamic and layered. The sauce no longer appears continuous. Some structures look broken or partially collapsed. This reflects the intense processing that tomatoes undergo during ketchup production. Despite this, much of the original plant structure remains visible. The image feels busy and complex. Every area is filled with detail. At this scale, ketchup no longer resembles food at all. It looks more like a microscopic construction made from organic fragments. This magnification reveals how thickness, color, and texture are built from countless tiny components. At 2,000 times magnification, ketchup becomes completely abstract. Nothing here resembles a sauce anymore. Individual structures are now sharply defined. Thin walls, irregular fragments, and tiny particles fill the frame. Some areas appear tightly organized, while others look chaotic and fragmented. The background is crowded with microscopic debris. These particles create a dense visual field with almost no empty space. The image feels alive with detail. Rounded shapes sit along sharper edges. They follow contours and collect in specific zones. This repetition creates subtle patterns across the scene. At this level, ketchup looks less like food and more like a microscopic system. A system formed from plants, processing, heat, and chemistry. This hidden world exists inside something millions of people eat every day. Yet, it is never seen. Looking this closely changes how familiar food feels. If this microscopic side of everyday products surprises you, there are many more things waiting to be explored. Leave a comment with what you want to see next and follow the channel to keep discovering what's hiding beneath the surface.